Hi Year 11, welcome to your video tutorial. This video tutorial is intended for students completing the Stage 6 Software Engineering syllabus, first unit of work Programming Fundamentals, and the very first syllabus dot point, Software Development. Information and images gathered in this presentation have been sourced from Software Engineering, the Year 11 course, unless otherwise stated. The third stage of the software development cycle is the design stage. Now, just a bit of a disclaimer or pre-warning, in the design stage and in the following video, we are going to drop quite a bit of subject-specific terminology and not so much gloss over it, but just give the highlights. We're going to talk about a lot of new concepts in this dot point and not go into too much detail. The intention of this dot point isn't for you to understand in depth all the varieties and exactly what every data structure and data type is. Rather, that will be gone into more detail in the coming dot points. Today's focus is to say, okay, in the design stage, what is it that we actually do? However, I am going to drop quite a bit of subject-specific terminology in the coming slides. So the design stage is really about the creation of system models that'll be used to identify and determine appropriate structures and what algorithms needed to be determined prior to coding the solution. That is a big fancy way of saying we plan. The design stage is not so much making pretty UI drawings, which is important in this stage, but it's more about the design of the solution. I think a lot of students coming into software development, when they think design, they think visual. This stage is probably the exact opposite to that. The majority of what software developers do in the design phase is the designing of algorithms, the designing of data types, and the designing of data structures. Those three things. Algorithms, data types, and data structures. So what do we mean when we say that? Well, I've just dropped this word algorithm. An algorithm is a series of steps used to transform whatever goes into something to come out. And your teacher will probably take you through a number of real-world algorithms, so removed from the development or the coding environment, but give you an understanding of what algorithms could look like in the real world. They're just a series of steps that take something in to transform whatever they take in to an output. It's a way of solving a problem. Now, what you do in the design phase is spend quite a lot of time designing the algorithms that are going to make up the system. If this is not done at this stage, developers will inevitably paint themselves into a corner. In the coming dot points, we have a whole series, a whole unit of work on designing algorithms. So we're going to go into a lot more detail in this later. The next concept in the design phase that is thought about is data and data types. So data is the raw material in which the program operates. Programmers have to spend a lot of time considering the data that's coming in and how you transform that and what data needs to come out. So depending on what the type of data the data type that would come into the system, depending on what the system is. So for example, you might take keyboard input from a user in terms of inputting data into a calculator. That data type inevitably, if it comes in from keyboard input, would have to be transformed from a string, because later on you will find out how all keyboard input is not predominantly in most programming languages taken in with a string, even if they type in whole numbers, how that then gets transformed to actually output a calculation or display some kind of calculation to the user. Now, listed on your screen here are the main data types. So this is the word that we will use for all of the example data on the right-hand side moving forward. So an integer is a whole value. A floating point, that's negative and positive. A floating point is a decimal or a real number. A string is a fancy new word that we are going to use called alphanumeric. So a string can be alphanumeric. That means letters, what you would traditionally call letters and numbers. You can see from this middle example here, This is alphanumeric data. A really common example for strings is anything that doesn't require a calculation. So a street address is often taken in as a string, as is a telephone number, particularly for international dialing where you have the plus at the front. Boolean we use a lot in checking in our algorithms. It is a yes or no or a true or false. Boolean can be true values, true or false. So you can represent that with yes or no or true or false. The date data type, which will come in a variety of different forms, and the currency, which just depends what is commonly a floating point with a dollar sign. However, how that data type is handled is its own data type because it particularly gets handled in a different way. The last, and this is where the most amount of subject-specific terminology is going to come in, is the design of data structures. So we kind of said, you have to plan out the steps with algorithms. You have to consider the types of data that come in. These types of data need to be stored somehow in some kind of container. And we're going to go into a lot further detail in subsequent dot points on what different data structures are. This data that comes in, say we take some input from the user on a keyboard, your program needs to store it in something. It needs a container to store it in. So it's very, very, very important to consider, well, what type of data needs to be stored, and therefore what do I need to do with it? Now, in data for software engineering, which is a subsequent dot point in this topic, guys, we talk about each of these in incredible detail. So you will find out that, look, an array is a list of, it's comparable to a list of data all of the same data type, what stacks are, what sequential file and how it's read in, and how it's different from a record and trees and hash tables. If for the moment you can simply jot down these data structures or these containers, have these in your notes, and know that in the design phase, developers spend a significant amount of time designing and planning out these data structures. So not only when this data gets input into the system, it can be held in an appropriate container, but that data then can be used within the system or transformed within the system in a manageable data type. Remember that. Make a note of that, because we're going to come back to it and it's going to make a lot of sense in the later chapter. And that's it, guys. The design phase of the software development cycle is the design, planning out, and consideration of the variety of algorithms, data types, and data structures that will be in the software system that you are designing.